Hello guys, welcome to our chemistry demonstration. My name is Aiden.
My name is Chris.
And today we are going to be doing a demonstration on how mirrors are made. We are going to be working with this watch glass right here, watch glass, and various chemical solutions to plate this watch glass with a silver coat, which makes a mirror.
And this reaction is considered electroless plating because an external power source is not required in the plating process.
Before we start the demonstration itself, we gotta make sure we're wearing all our safety equipment because we're working with pretty harsh chemicals. Got our gloves on, our chemical splash resistant apron, and our gloves to protect our eyes.
And again, we're working with sodium hydroxide and ammonium nitrate, which are really corrosive and can damage our skin and our eyes.
Okay, so prior to our demonstration, we prepared 3 solutions. We did that off camera because they take a little bit of time. It involves boiling and cooling and boring stuff. Beaker labeled number 1. This contains 100 milliliters solution, and the solution itself contains 5 grams of sucrose and 0.6 grams of tartaric acid. We will refer to the contents of this beaker as RCHO, where the R stands for an attached group to the CHO, which stands for the sugar itself. Quick solution question. What is the molarity of the sucrose within the solution if there's 5 grams of sucrose and 100 milliliters of solution? The chemical formula for sucrose is C12H22O11. Okay, so the molar mass of sucrose is about 342.3 grams per mole. So using dimensional analysis, we should be able to get about 0.015 moles of sucrose in solution. If there's 0.015 moles of sucrose in 100 milliliters of solution, it should be about 0.15 molarity.
Beaker number 2 that we prepared here contains also 100 milliliters of solution containing 4 grams of silver nitrate and 6 grams of ammonium nitrate.
And then our last solution right here, beaker number 3, contains 10 grams of sodium hydroxide and 100 milliliters of solution. Another quick acid-base question. With the 10 grams of sodium hydroxide and 100 milliliters of solution, what is the pH of this solution? The molar mass of sodium hydroxide is about 40 grams per mole. If we have 10 grams of sodium hydroxide in solution using dimensional analysis, we find about 0.25 moles of sodium hydroxide in solution. And because of stoichiometry, NaOH dissociates into Na plus and OH minus, and it's a 1-for-1 mole ratio, so it's also 0.25 moles of hydroxide ions. The molarity could then be calculated using moles per liters to get a molarity of 2.5. Then, rearranging our equation, 14 equals pH plus POH, to get 14 plus the log of OH to equal pH. We can input our given variables to get a pH of about 14.4.
Okay, we're currently under the fume hood right now because we are washing our watch glass with nitric acid before we do anything on it. And this is because unlike water, nitric acid will remove ions from the watch glass so that it is ready to have other chemicals on it. And before we do so, make sure you have protective equipment because again, nitric acid is very corrosive and can damage your skin.
So after our acid wash, we're just gonna wash off the excess nitric acid with I'm gonna use deionized water. You could really use tap water, it doesn't matter. Just to get that excess nitric acid off. So our first step in this process, we're gonna take 5 milliliters. We're just using a graduated cylinder here of solution 1. I already poured it in just for time's sake. And we're gonna just add it to our watch glass, and we're just going to coat the entire surface with it. For about a minute.
All right, so for our next step, we prepared 5 milliliters of solution 2 and 5 milliliters of solution 3. And we are going to combine these and mix it in a beaker labeled 2 plus 3. And when we do mix these two solutions together, they will form a precipitate. And the chemical equation is shown here. The precipitate will immediately react with the ammonium nitrate in solution to create what is called Tollens reagent. And the second chemical equation is shown here.
Because this reaction occurs fast, we are going to mix these two solutions quickly and immediately add to our watch glass with the solution one already on the watch glass. Immediately after we do that, the watch glass is going to start to be coated with silver. The reaction for this step is as follows. I'll keep that up there. The reaction for this step is a reduction and oxidation reaction. In this reaction, which one of the substances are going to be reduced and which are going to be oxidized? I'll give you some time for that. The RCOO group in the products has an overall charge of -1. That's important to note. Okay, so analyzing the reactants, we know that the carbon in the RCH group is +1, since hydrogen is +1 and oxygen is -2. In the silver ammonium hydroxide complex, nitrogen is +3, hydrogen is +1, oxygen is -2, and Ag is +1. Now we can look at the products. Because the RCOO group contains 2 oxygen and 1 carbon, the carbon must have an oxidation number of +3 because the group itself has a -1 charge. Additionally, our silver, because it is elemental, is 0. Nitrogen stays +3, hydrogen stays +1, oxygen stays -2. This shows that carbon goes from a +1 to +3 and silver goes from +1 to 0, meaning carbon is oxidized and silver is reduced. When we mix solutions 2 and 3, look closely. You should see the solution become darker and a dark substance precipitating. That is our Ag2 oxygen precipitating. So now we're going to do the reaction itself. And again, we're going to mix these two solutions right here into this one and quickly mix it up because it is a fast reaction, and then add it to the watch glass. And as I do this, you should see the solution that'll be in this cup start to turn dark. Ready? Mix that up. Now we're just going to rotate this for about 5 minutes, making sure to coat every single side of it.
After we stirred around the solution for about 5 minutes, we're going to empty the rest of the solution into a waste beaker that we already did. And because we want to save the excess silver precipitate, we will acidify the hydrochloric acid and claim the silver chloride that remains.
As you can see, we have our excess solution in here. Again, so when we're working with these strong acids, because they are really just gas molecules dissolved in water, we do it under the fume hood, because when we open the container, the gas particles will release out of the container and will be corrosive if they get into your lungs. So we're going to do this under the fume hood. And as you can see, we have our solution right here. And as soon as we acidify it, we should see some precipitate. So as you can see, we have a good amount of silver precipitate. This is silver chlorate. I will put the equation for this up on the screen now. But there's a good amount of that. And what we're gonna do is we're gonna put this on some filter paper and we're gonna filter all that out. As for now, we are going to check the results of our experiment and see how much of a mirror this is. See, this is the side we did the experiment on. It's not really a mirror because it's the back side of it. The real is on the other side. So ready? There we go. That is how mirrors are made. And there is a bit of tarnishing, but it's what you can expect from a laboratory experiment. I'm sure if we had professional grade equipment that we could get this down to no tarnishing. But that's pretty good. If I had to fix my hair, I would use the mirror to do that. So right now we're just using the water squirter to get all our silver precipitate out of the beaker, and then we're going to filter all this solution into this beaker right here, and hopefully we should be able to collect all of our precipitate.
Before we go neutralize our solution, in the meantime, we're going to just dry up our filter paper so that we can obtain our precipitate.
Okay, so now that we have all our strong acid solutions together, we are going to now neutralize it for safe disposal. So I'm just going to put this solution into the nitric acid solution from earlier, and we're just going to use some sodium bicarbonate to neutralize it. You guys might know that as baking soda. So after almost complete drying, we have our silver chlorate precipitate.
We hope that you enjoyed doing this experiment.
I know we did. It was a very fun experiment, I think. But yeah, thank you guys for watching. If you enjoyed it, maybe try it yourself. But again, be careful. There's a bit of chemicals that you have to use. Other than that, thank you guys for watching.
Thank you.